Greetings and welcome to the Pure Report. I'm your host, Rob Ludeman. It is time to bring the orange as we continue to march through the 15 architectural decisions. And if you've been watching the series up till now, you know that I've got Andrew Miller and JD Wallace in studio with me. It is super exciting to have you both here, and I hope everybody's enjoying this series. We are going to be diving into the next three that we're hitting. We're going to be hitting snapshots, we're going to be hitting efficiency metrics, and we're going to be hitting RAID. And with all these episodes, of course, we're going to talk a little bit about what it is, how it compares in the industry, and why it's important for customers.
Why do you care?
Yeah, why should you care? Why should you consider this thing? So without further ado, let us dive right in. And this is one that I absolutely loved. I started my career here at Pure many, many moons ago doing database marketing and, snapshots being a really, really important thing in the database environment for pulling off data for people to do dev on, non-prod, all those great things. But it is
phenomenal power.
Phenomenal power, yes. But one of those things that's important to us because of the function, itty bitty living space.
You got it.
Yes.
Look at that.
I eventually came around. I think I watched that movie about a week ago. But something really, really important in the functionality of businesses. So let us dive in. Andrew, you want to take it on first, like our view on snapshots and why they're so critical.
So maybe a little bit of what it is, and we're going to have to do a little bit of history as part of this. So when we were looking at this title, there's snapshots. It can be really usable snapshots. It can be immutable snapshots. All of those are true. Sometimes I almost like to say, I almost don't like the word snapshots sometimes, just because everybody has probably worked, almost everybody listening to this, has probably worked with another system.
Some other kind of snapshot.
And they had all these kinds of snapshots. They were copy on write. They had performance impact. You got stuck with chains. You deleted them, and there was random crawlers in the background freeing up blocks. So all this stuff that's associated with the value of snapshots, which should really be synthetic ways to protect your data and make point-in-time copies. So sometimes the way that I refer to it is snapshots on Pure are what snapshots want to be when they grow up, if you will. So imagine all the hopes and dreams and aspirations that you had for snapshots in the past and forget all the problems. That is largely what we're doing here. So snapshots, you can make them instantly on any volume. When you create them, they take no space, even as they diverge from the delta. The space deltas are deduplicated and compressed. They are immutable by default, which is a fancy word for read-only, but it means you can never modify a snapshot. You're like, so what can I do with the snapshot? Well, you can copy it to a new volume instantly, just like you can take it instantly. You can also copy it over top of an existing volume with an extra, do you really want to do that check? You can also do that instantly. That's some of your classic, let's go back to databases, Rob. It's a little bit of production to test dev, refresh kind of stuff.
Yes,
so
classic.
This is a core building block. And what enables this is a decision that we're going to be hitting on a little bit later, the metadata architecture. So if you're thinking there should be cool stuff about metadata mapping and how that works, we'll actually save that for a later one. But snapshots is actually this very tangible result of our really strong metadata engineering kind of thing.
Yeah, it is fun how these are all connected, right? And I love that you're making those connections also because it helps us forecast the future episodes that we're going to be doing. But you start seeing a common theme here that everything really is connected.
It really is. And if we go back to, and we've talked about this throughout this series,
right?
But if we go back to kind of the genesis of the 15 architectural decisions and how we started really kind of writing them down and talking about them, it was in the early days of the company when we were still getting lots of FUD from our competitors about the way we chose to do things.
Right.
And this is another great example of that. We talk about snapshots a little more holistically now, but in the original version, it was specifically immutable snapshots.
Right.
And why is that interesting? Well, it's interesting because many of our competitors at the time were trying to introduce FUD against us saying, oh, you have a snapshot that you can't mount and change. Well, what if I want to take that snapshot and do something with it? And so immutable snapshots was kind of seen as a disadvantage. We said, no, that was actually really intentional.
Deliberate choice.
It was a deliberate choice because it saves user error.
Right.
And we can still make those changes if we need to. We just make a clone. And because of the data efficiency engines, the dedupe and the compression that we already talked about, these take no space, as Andrew pointed out. And so it's really, really low cost to be able to do this. And ultimately, we're making emotional connections with the customer when we talk about how we are getting rid of data. So for example, we don't just say you delete a snapshot. We say you destroy a snapshot.
It's a big deal, not to be done casually.
Right.
I mean, destroy carries that emotional weight. And then if you want to actually really get rid of it, it's not gone yet. We save it for a little while in case something happens. You need a get out of jail free card. So you say, I want to destroy this. Okay, well, we're going to keep it for a little while. And if you want that space back right now, you eradicate it. So destroy and eradicate.
Another powerful
really
word.
Powerful emotional connections back to what we're trying to do here.
Yeah.
Not the usual words you'd see in an interface.
No.
Intentionally to kind of make you stop and think that this is different. I think there are two other foundational pieces I wanted to put in. One is kind of what this isn't. I used to have systems where you create snapshots and they were all chained to each other. So you had snapshot chains. You wanted to get rid of one snapshot in the middle. Well, you couldn't. It would actually remove all the ones that were newer than that. So all snapshots are independent. And the reason that you can do that is now just a little bit of metadata commentary is that every time a volume is actually a representation of metadata that is mapped to the data. And any given metadata block, there may be multiple metadata blocks mapping to the same data block. That's the definition of deduplication, right? Kind of thing. So hopefully that's clicks quickly for folks listening. When it's a snapshot, you basically say, I'm going to do a point in time freeze of that metadata. And so I have a representation of the volume at a metadata level. Now we're already doing the metadata to data tracking separately. So the snapshot process doesn't have to think about that. That's at the core metadata architecture level. And so every time you take a snapshot, it's a new set of metadata, which is why it can truly be instant, not just a claim, because it's a metadata operation. And what do we do all the time on the array? Metadata operations, nonstop, every single second, millisecond, microsecond, whatever. The array is really a metadata engine, a key value store, if you will, kind of thing.
This is also where the space efficiency comes in as well, right? Because you have these
The metadata
pointers, right? So all it is the mapping that points to that, whereas it's not just the core copy of the data, right? And so that's why, kind of sneaky advantage that we also get into is you can do a lot of snapshotting without impacting the amount of capacity that you're using on the array.
So then snapshots become this interesting foundation for a bunch of other things. So I love, Jay, that you were kind of going to like immutable was this intentional decision because it was seen like, oh, you should be able to modify your snapshots. We're like, no, that's not a good idea. But based on both the metadata architecture, the immutability, we actually use snapshots as the foundation for our asynchronous replication. That's where, it's periodic snapshot shipping and just the deltas, and there's time frequencies there. Of course, there's further replication options that go into continuous, that's active DR, or into synchronous, that's active cluster. But snapshots were this awesome building block for the initial replication method. The piece that you also talked about, JD, when I joined Pure about 6 years ago, I came from a company and did a lot of stuff around ransomware. And so I saw what we were doing with the eradicate and destroy process. I think you probably even remember this, Rob, that, well, of course, not even remember. Yeah, you remember all of this stuff. You've done so many of these podcasts. Originally that was built as an admin get out of jail free card. It was like I deleted the wrong thing.
It was the oops thing. Yeah, it was the oops button.
And can I get it back? And I've literally talked with admins who have actually used that to get themselves out of jail, or like they deleted the wrong volume kind of thing. And then we realized that we could take that default 24 hours in the eradication bin, call it like a recycle bin, and we could harden that and extend it out. And that became the foundation of safe mode, a feature that it wasn't necessarily built to help with ransomware or cyber resilience, but it has the biggest applicability there because now we're getting into what if someone compromises administrative access on your storage or data protection systems. Immutable snapshots help when it's external actors. They don't have access on board yet. But if you want to protect from that next threat scenario, we could actually use eradicate and destroy and snapshots that can't be expired sooner than that timer to build a feature called safe mode. So this foundation has played out into stuff that is insanely relevant today. It's almost crazy how applicable it is.
And you mentioned something that I think is kind of interesting. We didn't initially, we're talking about the foundational architectural decisions. Safe mode was not a foundational architectural
Came
decision.
later. Yeah.
But it came out of the really deliberate things that we did as a precursor.
If we didn't choose to be immutable,
if we
could we have done safe mode?
If we hadn't chose to be immutable, if we hadn't chose to think about the customer workflow of how I delete data,
Two-step process.
Yeah. If we hadn't spent the time to think through those kind of operational underpinnings, we never would have been in a position to build something as impactful as safe mode.
Or it would have been a whole nother engineering effort that would have taken longer, right? That kind of thing. But at the same time, we also took our time to get it right? And that's something that generally is a hallmark that I'll throw out, and I haven't put it into any of the episodes yet, is, I remember when I joined something like replication, like Active Cluster was coming out, and people would question like, why haven't you guys, everybody has that. It's like, no, we want to do it right. Right. And so that's the same kind of thing with safe mode here. But Mr. History Professor over there goes back to, if we weren't immutable in the first place, safe mode would have been a more challenging thing to bring out.
I'll do a customer story or two to finish this out, and then Heather lost that. So we hit on one. There's been admins who literally you have a get out of jail free card around anything that you delete, kind of thing, so you can roll back. The thing is, well, actually, I believe this blog post is still up on the Pure website. If you put in ransomware and hospital, you'll actually find a hospital that got compromised, and even without safe mode in play, where it went to later, the immutability of snapshots, they were actually able to roll back based off immutable snapshots. And I'm not going to say at this point that immutable snapshots are just the existence of them is tremendously different from other companies out there, but the way that we've implemented it, and usually once I get into this with customers, when we go deeper into the life of an idle presentations we talked about before, you start to see how it's actually done differently enough that a lot of the problems you might run into in the past. And then, of course, last but not least, and now this is going to play into, we mentioned this at the end of the data reduction one, how data reduction helped make Flash affordable, but it actually made the cloud possible for us. So Cloud Block Store as a capability. So I'm thinking of a customer who actually was on-prem and was told, you must go to the cloud. And they made 8 to 10 copies a day of their production databases, and they couldn't do that in AWS. I'm not knocking our partnership with AWS. There's just not pointer-based snapshots in their block store. It's not what they do, what they did at the time kind of thing. And even still maybe now. So Cloud Block Store and actually our same snapshot capability that started with FlashArray 10, 15 years ago is what actually enabled a classic business process in the cloud that they wouldn't have been able to do otherwise.
And about the second or third time that we've brought up this feature functionality, things that are in Purity that are core, also being beneficial in the cloud, even on their own, right? Which is really, really interesting. Okay, I think we hit that one. Nothing further. You want to put a bow on snapshots, or we hit it enough?
Well, I think with Andrew, and I don't know if you did this on purpose, but he's a clever guy, so we'll give him credit for it.
Is.
But you actually set us up really nicely for the next one, realistic efficiency metrics, because we've talked about in a previous episode, we talked about data efficiency, deduplication, compression, those kind of technologies. And now we've just talked about snapshots and the fact that I can now instantly create many copies of something. So I'm creating more and more data.
Oh, I'm not creating data. I'm creating more pointers to the data.
Good catch. But what I've done now is I've given myself, if I'm thinking a little nefariously, an opportunity for some creative math where I can say, well, hey, if you've taken 1, 2, 5, 15 snapshots of your data, now you have 15 additional representations in addition to the first one. Well, if I'm deduping all that, do I get to count that? Do I get to count every single one of those as an extra duplicate that I've removed?
What I'm feeling is we all just finished annual review time here. So we had to think about how do we take the metrics that look good as we put it into Workday, or otherwise we're a little bit of flavor of that.
You're hitting on, that's when we go into this next one with the efficiency metrics is, I think people running storage get bombarded with statistics and with analytics, and you can get into a rabbit hole truly.
Or there has to prove their value.
It has to prove their value, right? And I mean, anecdotally, I just had my son up meeting with a junior college baseball team, and they showed us some program where they take film of 6 different angles of pitchers, and then you can go through on a menu on the side and pick a 1-2 count and the type of and they said, we don't let our players look at this because you can get into a rabbit hole. You can get too distracted
inside your head too
and
much.
Way too granular. And so the key is then, what are the things that admins actually need to view? What do they really want to see? And how do you make it really easy for them to see that? And that's where we get into these efficiency metrics.
Yeah.
I think my subtle segue gets a B and yours gets an A+. So, look at that.
It's always sports or movies or
But it works.
80s pop culture for me. But do yours.
Yeah. So realistic efficiency metrics, realistic space accounting. Maybe I'll play a little bit of Mr. History this time, JD.
Okay.
I think. So
I'm intrigued.
So let's go back. I actually remember, and this was now when I was in the partner space, and you would actually see stuff about, hey, when we're talking about deduplication, does it include things like, do you get to count, and you see the ratios of like, especially when it was in backup repositories, something called something domain. Okay, people probably know before they got acquired and then later got renamed. So, hey, you're getting 3 to 1, 5 to 1, 10 to 1. And then once data reduction or deduplication started to come over to the primary storage space, it's like, well, do you count compression on that? Maybe, probably. Okay, what if you have thin provisioning and you haven't actually consumed all the space yet? Do you get to count that? Well, it feels like kind of a little bit further because I allocated a ginormous amount of space, but I've only consumed so much, so it looks really good, right? Well, and what if I make lots of snapshots? Well, that's an extra copy of the data. What if I clone all that? And you start to get to this world where you could have all these different numbers, like you were saying, JD. And depending on the vendor, any given dashboard will look different. So when we started as Pure, we said, hey, we should focus on what actually matters and count deduplication and compression and not count thin provisioning and snapshots. Although at one point, actually, you could actually see in FlashArray's GUI, you could actually see both numbers because it was this actually apples to apples thing. Okay, if you're talking with this vendor and you're the admin, you should use this number to get an apples to apples. But we still believe this is the way that we should actually measure it, kind of thing, recognizing the competitive world, but being honest.
It comes down to an intentionality, right? Are you building these metrics to show the user valuable data that they can make decisions on? What is my efficiency and when do I need to plan for expansions and those sorts of activities? Or are you simply trying to put the biggest mark on the scoreboard that you can so that from a competitive perspective, you can say, mine's the best? In doing so, you've eroded all possible user value from that data. And we said, we're not going to do that. We're going to present a customer-focused, realistic value that doesn't take into consideration thin provisioning, snapshots, or cloning.
And the reason there was because what would you actually do with the right value? It would link into your storage forecasting. And this was before the days of what we do with Pure One today. So side call out for later. There's great stuff in Pure One that actually shows, your predicted growth based on all the past history, et cetera. But you would use those numbers and you need an accurate view of those numbers in order to do storage forecasting about storage growth. If you had really mushy numbers, you had no chance of doing that as a customer, kind of thing. This even led a little later into just our whole philosophy around metrics and reporting. And we already hit on load meter a little bit, but I'll pause myself. I know you had a little more there, JD, about load meter and some of just the overall approach to metrics.
Yeah. So if we take this concept of, user-focused metrics to the next level, we can think about lots of different metrics in the system, not just the data reduction, but we think about what is the actual hardware itself doing? What is the CPU doing? What is the memory doing? And I think classically, a lot of admins, myself included at the time, we're kind of tuned to think about those things. Well, I need to, just like a server, I need to keep track of what are the different utilizations of the pieces of this system so I know if there's a potential problem.
Is that something you were always fretting about and worrying about? It was constant, right?
You always kind of knew just whenever you didn't watch was when something was going to go wrong.
Yeah.
So it was just kind of in the back of your mind.
It's the watch pot.
Well, and you feel cool as a data center admin. You got your graphs up there with all your different numbers. And
blinky
dashboards.
lights.
Yeah.
But what Kaz likes to say is, especially when we think about CPU, is, there's a lot of it in there, and I'm going to use as much of it as I possibly can. I'm going to put it to work. If it's not doing something else, I'm going to run a service that gets you better data reduction.
Yeah.
There's lots of things I can be doing with that resource that's sitting there. So it's actually not necessarily an indicator of a problem if the CPU is running at 100%.
Maybe actually on a Pure system, it's an indication of a problem if it's not running pretty high because we're not using it for all the other stuff we can do for a customer.
There's also the ability to say storage is not a problem, because that's another anecdote that I've heard frequently from customers where the call comes in at home at 10:30 at night and
You need
the
to
person that
eliminate.
owns the storage is getting ready to go to bed, and they go, "Oh, we've just this key application has just bogged down. We think it's the storage." And this customer tells me, they pulled up their phone, they pulled up Pure One on their phone on the app, and looked at all the key metrics, right? Not having to sift through hundreds or thousands of different things, right, to the key metrics, and went, no, it's running on this array, and this array is running just fine. Your problem is somewhere else.
You actually touched on another closely related but slightly different thing. So kind of closing the loop on the CPU and the memory side.
Right.
We made the decision to say, rather than exposing those discrete metrics, let's roll that together into something we call load meter and make that the concept of load.
Right.
Let's show the customer something actionable, the load of the system. But you actually touched on something else, which is when we think about whose problem is it, where is latency in the system?
Where's the bottleneck?
And one of the additional things we said was, okay, we could show a customer the actual latency of the appliance, the storage, but does that really help you, especially in that scenario when we're playing a game of whodunit and everybody's pointing fingers?
Mean time to innocence.
Yes.
So we said, well, is there a way? We have visibility to the storage network. We're sitting on the storage network. Can we actually calculate SAN latency?
Yep.
Can we tell you not only what is the latency once the flash array gets the I/O, but what's the latency to actually get the I/O to the flash array?
Across the fabric.
And once you have that, that becomes a tool we don't talk about as much probably, but a very powerful tool
Super powerful.
in that whodunit game.
Yeah. Yeah.
We even extended that further into Pure One with what we call VM analytics, or actually the view of from the SAN out to the data store, out to the volume, out to the VMDK. So some of that same trying to do worthwhile things with metrics, and not here's just a whole list of things that you can't actually do anything with.
But that's where I was going to close this segment up, was much as a parallel with the other architectural decisions we've gone through. It's a thing where there was a foundation, right? There certainly was a decision about what we wanted to focus on providing metrics.
There's a philosophy.
And a philosophy, but then we evolved and got better. There was VM analytics, or I remember being close with the engineer who was doing the workload planner and the workload simulation. And when he was telling me, oh yeah, we're just measuring traces off the phone home data, and we can actually tell it's an Oracle database or it's something else. And then based on that, we can take all the data that we have, and then we can help people simulate like how their arrays are going to run and operate. And I was blown away. I was like, what do you mean you can tell? He's like, yeah, we understand. We've looked at the patterns, but there are things where we've added more value without creating more noise and more distraction, and focus on the things that really matter. It's a fun segment.
I think we're into the last one.
It's at the last one. Let's go into RAID. And for the folks that are really, really knowledgeable or really into the storage area, RAID's been around, right? RAID is a thing that goes back how long? You probably, both of you, had some
30, 40, 50. I feel like someone's on Wikipedia right now checking for the date and say like, oh, they're not credible.
Yeah,
They don't
they're
know
not
the date when
credible.
RAID was
And it's
invented.
not off the top of our head.
But I know the meetings.
Yeah.
I do remember in early days of my career as a very junior admin, questions about, what are the different RAID levels and what do they mean?
0, RAID 1,
0,
RAID 5,
1,
RAID 10.
5, 6, 10, 50.
Yeah.
There were some other ones, but those are the main ones, I think.
Well, and then we started getting crazy
No, not
and
60.
making up our own names like RAID 3D, but that actually means something different, doesn't it?
RAID HA. So RAID, redundant array of inexpensive disks,
Yep.
or redundant array of independent
Independent.
disks. I think we can you can use either one to check your bingo card. If someone's playing the at-home game, kind of thing. So this was the thing about we talked about data reduction, and these all interlock. RAID for flash or adaptive flexible RAID. Sometimes those are the two ways we'll talk about it. So we talked about like with data reduction, what's one of the ways that you make flash last longer? You just write to it less, fundamentally. So there's a piece of RAID that's about resiliency, but there's also a piece of RAID that's actually about writing less. So kind of going through a little bit of the resiliency thing first. So we started with saying instead of having dedicated SSDs, drives, whatever you want to call it, we're actually going to do variable length. And we're actually going to pack, as you mentioned, all the random data coming in kind of thing. And we're actually going to pack that all together and then write it down and actually do what we call write groups, and there's segment size, and there's all these pieces under the covers. But instead of having dedicated drives, we're actually going to do sub-drive RAID. That's the easiest way that I found to explain it to folks. And it's actually somewhat variable based on the data types that are coming in. And it was also based around knowing that any given time you had a flash die, and now actually our direct flash modules have multiple flash dies on them. Any given time you write to a flash die, it may or may not respond deterministically every single time. So you have to account for these variable random response times of the underlying components. You also want to think about, how do I not have one of the classic challenges of RAID? So I have to solve for resilience, and I have to do it with good performance, and I don't want to have major write amplification. But actually, I think I'm going to hold the write amplification thoughts for a second. So that's some of the core. We did things with ECC. We were planning for dual drive failure, and drives didn't have a natural home. That was even your previous example, JD, of like, hey, you could pick the drives up and juggle them around. Please don't. and then put them back in.
There are other reasons why you might not want to do that. For example, if we have to go unwind something from a support perspective, it might be nice to have a really good idea of where those drives are. But in theory, you could pull them out and mix them all up and put them back in a different place. We don't care. Try doing that with traditional RAID.
If you're not a good juggler too, and you drop one of them, no warranty there. So, but yeah. So the core piece is just as far as having RAID be adaptive under the covers and not bound specifically to drives. So if someone says like, "Oh, what's the hot spare drive on a Pure system?" There is no.
You can't point to it.
There's no hot spare drive.
Don't
And
worry.
That's intentional.
Don't worry about
There's
it.
hot spare capacity. And that actually is maybe I'll toss this over to you, JD. So what happens on a Pure system if you pull a drive out to the overall space? Let's say the system is 10 or 20% used. What actually happens?
Well, and I think you've highlighted this really well because we're not bound to specific drive geometry. We are taking the space that we need and using it in whatever way is necessary. So that particular drive may have data, parity, spare space, all of the above, all mixed within that drive. And now that we've broken the drive away from, or we've broken RAID away from the particular drive geometry, now we have a lot of flexibility in what we do in edge case scenarios. So for example, let's say I remove a drive. Well, I've just changed the physical layout of the system. That's okay. RAID just adjusts to the remaining drives that are there and continues to change the right size and continue to go.
You actually see, and you can see it says you will get reprotected. So your protection level will go back. So like I say, let's say you had another system where there are dedicated drives. You pull a drive out, then you pull the second hot spare drive out. Eventually you get to the point where you're running in a degraded mode. On a Pure system, as long as there's space, we'll actually reprotect you, or we'll rebuild from parity if needed, kind of thing. And then you'll actually see your total usable space drop down. That's not scary. You're actually running fully protected from a RAID standpoint. And as soon as you replace the drive that failed or that you pulled out, you will go right back up to the usable space. So it's a more intelligent perspective. And actually, we've sometimes had folks in POCs, and this is not recommended, where they basically try to see how many drives can I pull and watch the usable space keep dropping.
Yeah.
And because you actually don't need all that many, especially now, direct flash modules to drive a pretty high level of performance. So sometimes you can play that game. You can play that game pretty far, kind of thing.
The critical thing, what do people need to do or to worry about, right? I mean, we got all into the tech here, and I know this was a thing that was probably an admin task in the past, but this is another one of those, don't even worry about it, right? We do this for you.
You're right. I think a lot of this particular segment that we talk about was to kind of prove the backing behind a statement that we made,
Right.
which was the bottom line is we're always going to offer double drive protection.
Yeah.
No matter what, you lose 2 drives, your data's still there. And in the early days of the company, having some of the technical background that we just described was how we convinced people.
It was
that
important,
true.
of course.
But ultimately,
of course.
from a customer perspective, to answer your question, that's all you need to know.
Yeah.
You can lose 2 drives simultaneously and be totally fine. The other thing, though, is because of all of this dynamic geometry we talk about, because the system is essentially built to be efficient kind of no matter what, you have a lot fewer decisions to make.
Right.
You don't have, I'm sure we remember in our early days of, well, this is going to be a database, and so I want that on a RAID 0 volume.
For my logs.
Yeah, for my logs.
Maybe.
Configuration
10.
choices,
But
right?
I can't afford that kind of investment from a capacity perspective. So for my data volume, I'm going to make that something else.
You have all these trade-offs that you're having to work
Individual
through.
decisions, little silos, little
That
sets
was
of
that was a
disks.
big part of being a storage admin, wasn't it? Is making all those decisions. Well, I know the kind of for the workload, I need to go design the system this way. We don't have to worry about any of that.
Yeah.
RAID HA takes care of all of it.
So RAID 0, RAID 1, RAID 5, RAID 6, RAID 10, RAID 50, they all existed for reasons, like we just talked about. But you would have to decide that. So what if you said, and this is the core thing, and then you'd give the reason, the underpinning so people could believe it, but what if you could have the performance of the best RAID level and the protection of the best RAID level at the same time? And actually, oh, by the way, we're not going to give you a choice. We're just going to do it under the covers. So
Right.
we want you to understand how it's actually true, because we're not actually even going to give you that choice anymore, because that's the right thing to do once you understand how we can pull it off under the covers. And there are some pieces here of where we're only writing to empty blocks on Flash. Flash supports that well, kind of thing. So if you say, hey, the performance of maybe a RAID 10, but with the protection of a RAID 6. This is going back in the time machine a little bit, because for anyone who did stuff, RAID 6 was how you got dual drive failure protection, but it came with a massive overhead from a performance standpoint. And I think I may use that, at least the main last one that I know that I want to hit on, is that RAID always classically created a level of what was called write amplification. So you had, and let's go back to what we were talking about. Flash does not like writes.
Nope.
In the sense of you get to do so many writes, and then this flash sector says, I'm done. It's kind of variable, but it's within a range based on the type of flash. So if you have something like RAID, that by definition you have one write come in from the host, and then say if it's a RAID 1, it gets turned into 2 writes. Or if you have RAID 5, it gets turned, because it's right into two different systems. If you have RAID 5, RAID 6, it gets turned into 4, into 8. You can map this all. There's great Wikipedia articles that are history. But whatever you do is you end up having way more writes going down to the flash than are actually coming in from the host. What does that do to the longevity of the flash in your system? If you don't understand it intelligently, it dramatically shrinks it down. And so we actually got to the point where we could actually see in some internal things from Pure that based on what we talked about with deduplication, taking out filler data, deduplication, taking out zeros, a whole bunch of stuff, we could actually get, instead of our write amplification being inflated from what came in, we could actually get the write amplification below. So for X number of writes that come in, it would be 97, 95, 90% of actual writes that go down to the system and then intelligently packaged up. So this is where even the RAID approach goes to longevity of flash, that goes to the pricing to customers, that goes to less migrations, even if we make them non-disruptive and transient, less shuffling that we have to do underneath the covers in the system. So RAID even contributed to that core economic customer value.
That's a great why do I care?
It is.
Love it.
Yeah, we hit it right there at the end. The why do I care? That's a good one. And things that people don't really have to care about anymore, right? To my Carl, the admin that I used to go visit at large airplane manufacturer who would argue with us about things that we didn't require them to do anymore. This was one of those things where he's like, no, I get up every day to come to work to go do that and to map LUNs and do various things. Well, yeah, don't worry about it.
Well, and there's even the point here of, this is the whole, when there are I don't change my mind when there are new facts, I make new decisions kind of thing, or making a new decision. So all the stuff that we talked about, hopefully not kind of denigrating to anyone listening, but it was the right decision when you had X number of disks or X number of systems, et cetera. But once you get to a certain scale, as humans, we can't keep track of all this, or we can't hire enough of the people who can keep track of it.
Right.
Or you don't want to be keeping track of it at 2 a.m. in the morning. We'd rather sleep,
right,
kind of thing. So this is like, so can you pull off some of the approaches of the past? Maybe, but it's going to break at some inflection and scale point.
But I think that's a good theme that pulls all three of these together. When you look across snapshots and efficiency metrics and then this discussion on RAID, really the core is we've made life easier for the people managing the storage. And again, that's across the board for everything. But these three, the reason we grouped these is because they really go to the core of some classic problems and some classic frustrations that we've now fixed and we've now solved, right, with the design and with the decision. So good one. Job well done, gentlemen. Final thoughts? Anything?
We started at the beginning by talking about an example of a global financial customer who has 8 to 10x the storage admins or storage team that they do for the non-half, the half of their fleet that's not Pure versus the half of their fleet that is Pure. This is some of what goes into that. It's just not made up numbers. Now we stack these up through a lot of decisions, but this is one of the pieces that goes into that kind of difference in ratio.
Yeah. Ratio management, redeployment.
Yeah.
Awesome. Thank you, gentlemen. This was a super fun one to get through, and we got into the nitty-gritty, but I think also kept it at a level where it was educational for people to understand why we made those decisions and the implications. So job well done on episode 4, and thank you out there for watching this episode. And if you're listening, thank you for listening as well. Please share it out. Share the whole series. We'd love for people to get more around this information. That's why we're investing the time in just diving into all these really great areas around Pure technology. So with that, we will wrap. Thank you, JD. Thank you, Andrew, for Pure Storage. For Andrew Miller, for JD Wallace, this is Rob Ludeman saying, don't look back. Something might be gaining on you.